A computer just did in 5 minutes what would take every machine on Earth, running since the Big Bang, 10 septillion years to finish. And the most interesting part, we may have gotten help from parallel universes. The head of Google's quantum lab said so himself. This is the Willow chip. This is what it did. And this is why it mattered. December 2024, Google Quantum AI unveils a new chip, 105 qubits. The name, Willow. Google gives it a specific benchmark, random circuit sampling, a test designed to expose exactly what quantum computers do well. Not every problem, not email, not web browsing, this specific test. Willow finishes in under 5 minutes. The fastest classical supercomputer on the planet, Frontier, would need, well, let's get into that. 10 septillion years. That's a 1 followed by 25 zeros. For scale, the universe is 13.8 billion years old, a 1 with 10 zeros. Willow's task would take 10,000 trillion times longer than the universe has existed. Every supercomputer ever built, running in parallel from the start of time, still wouldn't be a fraction of the way done. Something has to give. That's the only way this number is possible. So how is it possible? Here's what Hartmut Neven, the head of Google Quantum AI, wrote on Google's own blog. Direct quote. It lends credence to the notion that quantum computation occurs in many parallel universes, in line with the idea that we live in a multiverse, a prediction first made by David Deutsch. Not a conspiracy theorist, not a YouTube channel, the guy who runs the quantum lab, on the official blog. David Deutsch is a physicist at Oxford. In 1985, he proposed something radical. When a quantum system makes a choice, when a particle picks a path, when a qubit collapses, Deutsch argued the universe doesn't pick. Both outcomes happen. In different universes, every quantum measurement splits reality. It's called the many worlds interpretation, and it's exactly what it sounds like. If many worlds is correct, quantum computers aren't just fast, they're borrowing computation from parallel versions of themselves, trillions of them, working in parallel, each one a little different. That's what Neven is pointing at. When you see 10 septillion years collapse into 5 minutes, something has to explain it. Many worlds explains it. But many worlds isn't the only interpretation. Copenhagen. The particle picks one outcome, the rest vanish. Pilot wave. A hidden guidance field steers every particle. Consistent histories. Relational quantum mechanics. Half a dozen more. All of them predict the same math. All of them explain Willow's result. Most physicists lean skeptical of many worlds. Scott Aronson, one of the field's sharpest voices, has pushed back. The interpretation debate is 100 years old and unsettled. Nobody disputes what Willow did. Everyone disputes why. And here's the thing almost every headline missed. The big deal wasn't 5 minutes versus 10 septillion years. That's the clickbait. The big deal was this. As Willow added more qubits, its error rate dropped exponentially. It's called below-threshold quantum error correction. The holy grail for 30 years. Nobody had ever demonstrated it. Willow did. Without it, quantum computers are fragile toys. With it, they scale, really scale. That's what made Willow historic. Whether Willow is borrowing cycles from parallel universes or doing something we haven't fully understood, the age of quantum advantage has quietly begun. And nobody yet knows how far this goes.